I want to do a quick review of linear functions and their graphs. Before I do that, I want to talk about some of the basics. This is what's called the rectangular coordinate system. It's also called the Cartesian coordinate system. It has two axes, and they are at a 90-degree angle to each other. The horizontal line is called the x-axis, and the vertical line is called the y-axis. Normally we just label these as x and y. The point where the x and y axes cross is called the origin. We also name the quadrants of the rectangular coordinate system, that is, the four areas broken up by the x and y axes. We start first where x and y are both positive, and that's called quadrant 1, and then we go counterclockwise to quadrant 2, quadrant 3, and quadrant 4. We do use Roman numerals to indicate the different quadrants. We also talk about things such as the x-intercept and the y-intercept. The x-intercept is where the line crosses the x-axis. That point is called the x-intercept. The y-intercept is where the line crosses the y-axis, and that's indicated by that point. We'll be using the x and y-intercepts in order to graph some equations. Notice that the x-intercept is where y equals 0, and the y-intercept is along the line x equals 0. We also need to talk about what the word function means. A function is usually written as something like f parentheses x n parentheses, but it's pronounced as f of x. You can tell if a curve is a function by doing the vertical line test. What the vertical line test is, if you take a vertical line and sweep it across the curve, or in this case a line, if it crosses that curve only once at a time, then it's a function. And we can see that this line is in fact a function because it crosses this vertical line only once, no matter how we sweep it across the graph. Before we talk further about how to graph equations, I want to show how you do this in my math lab. You'll have a question similar to this, and the best thing to do is to hit this magnifying glass. When you do that, the graph becomes much larger. If I want to graph a line, you click on the line, and then you plot your first point. You click, and then you move until your second point is where you'd like it to be, and click again, and then you hit save. There's many different ways to graph linear functions, and this all should be reviewed for you, so I will go through this rather quickly. What will be a little bit different in this class, though, is we'll do more in terms of word problem, and you need to be able to create the linear equations just from the word problem. For instance, if I had a car depreciation, I bought a car for $1,800 new. And cars depreciate over time, that is, they're worth less and less each year. Specifically, this car loses $300 each year. And so what is the equation that could model this? Well, we're going to let y equal the value of the car at time x. So the car is worth $1,800 minus 300 times x, where x is the number of years. So when x is 0, or that is when we first bought the car, then x would be equal to 0, and we would just have 1,800 minus 0, or 1,800. After 1 year, the car would be worth 1,500. After 3 years, the car would be worth 1,200, etc. This, however, isn't in the form that we're used to. We usually write things in slope-intercept form. That is, y equals mx plus b, where m is the slope and b is the y-intercept. Remember, the slope is the rate of change, or the change in y divided by the change in x. So our equation could be rewritten in the form y equals negative 300 plus 1,800. And this leads us to one way to graph a linear function, and that is if I have it in slope-intercept form. Graphing something in slope-intercept form, you start by the y-intercept. That is, in this case, the point 0, 1,800. And then you move by the slope. In this case, my slope is negative 300. I sometimes like to write that as negative 300 over 1. That means I will go down 300 in y and over 1 in x. And so that's my next point. And then I could keep going. I'd go down another 300 and over 1. Down another 300 and over 1, etc. And then you simply connect the points. And that is one way to graph linear functions. You start at the y-intercept and you move by the slope. Remember, a negative slope is oriented like this, and a positive slope is oriented like that. There's another way to graph a linear function, however, and that's if it's in standard form. If I wanted to write this same equation in standard form, what I need to do is move the x's and the y's on the same side of the equal sign and the constants on the other. So to do that, I would merely add 300x to both sides, and I'd get the equation y plus 300x equals 1800. Now instead of starting with the y-intercept and moving by the slope, I'm going to graph by the intercepts. To graph by the intercepts, you first let x equal 0 and solve for y, and let y equal 0 and solve for x. So let's do this. If I let x equal 0, I get that y is equal to 1800. So this is the point 0, 1800. And I'm going to go ahead and graph that point. The next thing we'll do is let y equal 0. When I do that, I'll need to divide both sides by 300, and I'll get that x is equal to 6, and that's the point 6, 0. So I'll plot that point. I've got my 2 points, I just connect them with a line, and now I've graphed by the intercepts. And it's the same graph as I had before. So it doesn't matter whether I graph by the intercepts or graph by the slope-intercept form. For most of the problems in this section, though, graphing by the intercepts is the easier thing to do, because a lot of the equations will be given in standard form. I just want to remind you about two special kinds of lines. That is a horizontal line, which has the equation y equals some constant, in this case I'll pick 6, or a vertical line, which would have the form of x equals a constant, and in this case I could say x is equal to 2. So these are two special cases of linear functions.